deep learning for building outline architecture. I'm Jesse Anttila from NLS. I work on this project as a research scientist. So to start with, the task itself is quite simple. We have these orthophotos. In practice, we use 2 orthophotos now, and we'd like to get these building outlines out of them automatically instead of using lots of manual labor. But in practice, it's not quite that simple, since there's a lot of challenging features in these images. For example, these shadows, which makes it very difficult to sometimes even manually find these correct shapes. And there's also these examples of buildings that are being constructed. They are sometimes can be in all kinds of different stages of construction, which are not so easy to detect automatically. Here these red lines are from the Topographic database, so these are manually added as a result of some process. And then there's these 2 examples as well of very difficult buildings. Like here's an amusement park on the left, which has lots of very unique buildings that are very difficult to even manually annotate, since it have some very interesting shapes, and here you can also see that these existing labels for these are quite out of date in some places. And on the right there's it's a metro station from Helsinki, which has a mall built on top of it. It has some very interesting features on the roof. It can be difficult to detect as well. So yeah, there's prior work on this topic, so quite a bit from various different agencies in different countries and so on. Here's one example from Israel. They have a model using a mask or CNN system for building detection, which works for most of these most common buildings, but here in this example image there's quite a few buildings that are not detected so well. Then the most important part is the data for this kind of project. What we have is 2 orthophotos, and this is our surface models for the capital region and 2 other regions in Finland. Also more are being made all the time, so that we can...
Sorry, Jesse, there is some noise coming from your microphone, so that if you could somehow, I don't know, I don't know what to do, but it seems that the microphone is speaking something else a lot also than your voice.
All right, I don't really know what else it could be. There's not really anything here. I had this issue before, and it was fixed by using a different laptop, but I can't help that.
Okay.
So you'll just have to bear with it for a while.
Yeah, we just have to live with this. Yeah, but try to speak up a bit louder, then we can be sure that it also will be recorded. So thanks.
Yeah. So we have these manually corrected labels for a large portion of the capital region and 2 of the smaller portions as well. The idea of this larger portion is to have a very general dataset that covers a lot of different buildings, and these smaller datasets are for ensuring that the model works in different areas, since there was some generalization issues before with different types of images and other image features that would be different in different areas due to the imaging process. And then we also have a set of building vectors from the Topographic database for all of Finland, but in practice these are not good enough quality for training in all areas. In some areas these are very high quality, but there's usually some outdated vectors as well. And there's a couple of implementation details I'd like to share here. It's that we are using a fully convolution architecture, specifically a unit variant, which is useful in that since it's fully convolutional, it can be used with different resolutions of images, but in practice it's better to use one resolution for training and inference, since this results in better results. Our input has 4 channels. there's the color channels, and we have another height channel from the DSM, which seems to have improved the results a lot over these few last months. And we use a lot of data augmentation, since there's a limited amount of data. So we use some flips, transpositions, rotations, and crops to multiply the amount of data in practice during training. And we also use input padding and output cropping for ensuring that every pixel of the sort of target area has sufficient amount of context from the input. So, for example, a 64 by 64 pixel image would produce an output that's, let's say, 48 by 48 with due to the padding, which can be then, since this produces an issue of not all of the images being labeled, we use this mirror padding to pad the input further to ensure that even these border pixels can be labeled. So in practice, you want to avoid doing this as long as you have additional data to pad with, instead of having to use this mirroring. Okay, and then on the results. So 3 months ago, it looked something like this. On the left is sort of best result, on the right is the sort of worst result. So here the idea was that over the course of the summer we make some more progress towards getting all the results to look more like the left and less like the right. And then also the same set, a similar set for right now in August. So on the left you can see there's a bunch of different buildings which all have some very high quality detailed labels predicted for them, and on the right there's a very unique building. Nothing like it exists in the training dataset, so it looks quite bad for this type of building. So the idea now is to move on to finding all these issues with these unique buildings and adding examples of them to the training dataset to ideally improve the results further. That's the first step on this path towards improvement, is to expand the dataset selectively based on errors that are found in the predictions. So we'll be going through a lot of results and finding all the worst cases, fixing labels for those and adding them to the training dataset. And then there needs to be more data added from different areas to improve the generalization in those other areas as well. In practice, once there's a good enough variance of data, it should be able to, the model should be able to be trained to work in pretty much all of Finland. And then there's some room for improvement in post-processing, namely the polygon simplification, since the resulting output from the model after some processing can be turned into these polygon vectors. We'd like to apply some simplification on these in a smart way to get simpler shapes for, since these buildings themselves tend to be simple shapes. There's usually rectangles and lots of right angles, and some have curves and so on. The idea is to apply a smart form of simplification on these polygons to more likely match the actual true shape, since the output from the model itself is quite messy sometimes. But yeah, that's it for today.